I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture, that is lecture number 9, we will briefly discuss about the next generation core, that is NG core for 5G. The next generation core, NG core, is a critical component of 5G networks designed to provide a flexible, scalable, and secure architecture for delivering diverse services and applications. NG Core is built on cloud native principles, leveraging software defined networking, that is SDN, network functions virtualization, that is NFV, and edge computing to enable the communication between devices, networks, and applications. And the first we look into the definition. The next generation core, NG core, represent a significant evolution in core network architecture, succeeding the evolved packet core APC of 4G networks, and it is designed specifically for 5G. And NG core aims to support the advanced functionalities and stringent performances requirement of next generation networks. Its primary objective are threefold: enhanced performance to deliver faster data rates and lower latency, scalability to accommodate exponential growth in devices and traffic, and flexibility to enable a seamless integration of diverse services and applications. By achieving these cores, the NG core empowers operators to deliver innovative use cases such as enhanced mobile broadband, massive machine type communications, and ultra reliable low latency communications, ultimately transforming the mobile ecosystems and enabling a wide range of cutting edge applications and services. First, we'll move on to the uh, NG-Core versus EPC, that is Evolved Packet Core EPC for 4G. The Evolved Packet Core EPC is the core network architecture of 4G network, providing a single integrated platform for managing mobile communications. And the EPC combines user and control plane functions, limiting flexibility and scalability. While it supports virtualization to some extent, its architecture is largely centralized and hardware based. EPC has enabled high speed data services and mobile broadband, but its limitations in scalability, flexibility, and latency have paved the way for the development of next generation core networks. Next generation core, NG core 5G. The next generation core, NG core, is a revolutionary core network architecture designed for 5G networks and offering significant enhancement over the previous one, EPC, that is Evolved Packet Core. NG core separates user plane and control plane functions, enabling flexible deployment options and improved scalability. With full support for virtualization and cloud native design, NG Core leverages software defined networking and network function virtualizations to reduce costs and increase agility. This architecture enables enhanced scalability, flexibility, and performance, making it ideal for diverse 5G use cases such as enhanced mobile broadband, massive machine type communications, and ultra reliable low latency communications. NG Core's advanced design empowers operators to deliver innovative services and applications with unprecedented speed, reliability, and efficiency. Next, this is the 5G architecture, and thus it consists of user plane part and control plane part. First, we'll see the UPF. What is UPF? UPF means user plane function. These user plane functions are responsible for managing data and forwarding the traffic in 5G networks. And UPF, that is user plane functions, acts as an anchor point for intra and inter-network mobility, and ensuring the data transfer between different network slices and domains. And the key responsibilities include packet routing, forwarding, and buffering, as well as enforcing quality of services, that is QoS policies, and managing user plane resources. By optimizing data traffic flow by optimizing the data traffic flow, UPF, that is user plane functions, enables low latency, high bandwidth, and reliable connectivity, and crucial for 5G applications such as enhanced mobile broadband, gaming, and virtual reality. And this control plane consists of various parts. This control plane functions are the brain of 5G network. One more time, I'll tell you this control plane functions or the brain of 5G networks, and it managing signaling, session management, and mobility. These functions include access and mobility management function AMF, and session management functions ASMF, and others. The control plane is responsible for setting up, modifying, and tearing down network sessions, as well as handling user authentication, authorization, and mobility management. Control plane functions enable efficient network resource allocation, ensure the handover, and provide critical network configuration and optimization capabilities. The next one is AUSF, Authentication Server Function. AUSF means Authentication Server Function. The Authentication Server Function is a critical core function responsible for handling user authentication in 5G networks. AUSF verifies user identities, ensures secure access, and prevents unauthorized network accesses. It stores and manages subscription data, security keys, and authentication algorithms, interacting with other core functions to validate user credentials. AUSF enables secure network access and protects user data and prevents potential security threats, ensuring robust and trusted 5G ecosystem. The next part is AMF. What does AMF have said? Access and mobility management function. AMF, access and mobility management function. This access and mobility function plays a central role in managing user access and mobility in 5G networks. AMF handles user registration, authentication, and mobility management, enabling the handovers between cells and networks. It interacts with other co-functions to allocate network resources, manage quality of services, and enforce security policies. AMF optimizes network performance, reduces latency, and ensures reliable connectivity and supporting diverse 5G use cases. The next part is NSSF, means Network Slice Selection Function, NSSF. The network slice function NSSF is responsible for managing network slices in 5G network. NSSF selects the optimal network slice for each user based on their subscription, quality of service requirements, and network conditions. It ensures the communication between network slices, manages slice specific policies, and optimizes resource allocation. NSSF enables customized network experiences, supports diverse 5G use cases, and allows operators to offer tailored services and different industries and applications. Next, we'll move on to the next function called network exposure function. This the main function of the network exposure function is what it will do is it exposes network capabilities and services to external applications, and it provides secure API based access to network data and function, and it supports what it will do is it supports slicing QoS and policy management, and it enables innovative services and revenue streams. That is the main function of network exposure, this NEF, network exposure function. Next, network repository function, NRF. What is the function of NRF is? See, that it manages and stores network function profiles and configurations, and it provides discovery and registration of network functions, and it supports services discovery and bindings, and it enables efficient network management and orchestration. This is the function of NRF. Next, we'll move on to PCF, policy control function. What is the main function of the policy control function is it makes policy decisions for network behavior and quality of service, and it manages policy rules and configurations, and this PCF interacts with AF and UDM for policy enforcement, and it ensures compliant and secure network behavior. And the next one is unified data management. See, unified data, UDM. In this figure, you can look into UDM. The function of UDM is it manages subscriber data, profiles, and authentication, and it provides unified view of subscriber information, and it supports real-time data updates and synchronization, and it enables personalized services and efficient data management. And the next part is AF. See here, the last one is AF, means application function. It represents external applications interacting with the network, request network resources and services, and it interacts with PCF for policy compliance, and it enables innovative services and applications. Next, we'll move on to virtualization and the scalability. And it comes under cloud native design. So what is the function of the cloud native design? That we'll briefly discuss. And the first one is the virtualization. It utilizes NFV, network functions virtualization, and containerization, and the dynamic scaling. It scales user plane and control plane functions independently. That is the main function of this cloud native design. Next one is what is the benefit of using this NG Core is it is cost efficiency, flexibility in deployment, and rapid adaptation to changing demands. These are all the main benefits of using this NG Core. So the first, what it is doing, the network slicing. Network slicing, all we should know. This network slicing is a 5G core concept that partitions network resources to create virtual networks tailored for different services and customers. Each slice is customized to meet specific requirements, ensuring optimal performance, security, and quality of service. Network slicing enables multiple independent networks to coexist on shared infrastructure, isolating traffic and ensuring confidentiality. And the benefits include, as I've said, the customization for diverse use cases. Example for this diverse use cases are IoT, EMBB, and URLLC. And isolation for enhanced security and reduced interference, and optimized resource utilization for improvised efficiency. The next one is identity management. Identity management is crucial for secured authentication in 5G network. This is very, very important property. IMSI based identity management, the traditional IMSI. What is IMSI? IMSI means International Mobile Subscriber Identity. One more time I'll tell you. International Mobile Subscriber Identity based identity management uses unique identifier assigned to each subscriber. IMSI is stored in the SIM card and used for authentication and authorization and mobility management. While widely adopted IMSI based identity management, it has the limitations such as security vulnerabilities, limited flexibilities. Next one is the non-IMSI based identity management. This non-IMSI based identity management introduces modern alternative for flexible and secured authentication. These include SUPA, Subscriber Permanent Identifier, NAI, Network Access Identifier, and External Identifier, that is username and password. That is the external identifier. This is the function of non-IMSI based approaches, and this non-IMI based approaches offer enhanced security through encryption and dynamic authentication, improved flexibility for diverse authentication method, and better support for IoT and machine type communication. So these advancements enable more secure, efficient, and adaptable identity management in 5G networks. So coming into the summary of network generation core NG core, the next generation core, the NG core is cutting edge, modular, scalable, and flexible core network architecture designed for 5G. NG core supports advanced features like network slicing, enabling more customized virtual networks for diverse use cases. Additionally, it accommodates various authentication methods, ensuring secure and adaptable identity management. NG Core's cloud-native design, virtualization, and dynamic scaling capabilities optimize resource utilization, reduce costs, and enhance network efficiency. And coming into the future perspective of NG Core, as 5G continues to evolve, NG Core will play a vital role in shaping future network architecture. Key prospects include evolution towards 6G. This is very, very important future prospect. And NG Core will lay the groundwork for 6G and enabling seamless integration with emerging technologies like terahertz frequencies, quantum computing, and nano networks. And 6G will require even greater scalability, flexibility, and intelligence, building upon NG Core's foundations. Next one is integration with edge computing and AI. NG Core will tightly integrate with edge computing, reducing latency and enhancing real-time processing. And artificial intelligence AI will be embedded with NG Core, enabling predictive analytics, automated optimization, and self-healing networks. The next feature is enhanced capabilities and services. The enhanced capabilities and services future NG Core advancements will unlock new capabilities and services, including ultra reliable, low latency communication, enhanced mobile broadband, massive type communications, and network slicing as a service, and secure and private networks. So, coming into the final topic, these developments will propel 5G networks towards even greater innovation, efficiency, and societal impact. Hope everyone understood about this NG core topic. The remaining things we'll discuss in the next lecture in detail. Thank you all.